Let's check your work from part 2, and you'll want to pay really close attention to everything I say here because there's some really tricky problems here. All right. Our first problem says no flower gardens are creations that feature skunkweed. Therefore, it is false that all flower gardens are creations that feature skunkweed. When we create a Venn diagram for our premise statement, we get this resulting Venn diagram showing that there are no flower gardens, no F that are also C. And that does seem to show also the conclusion statement, that it's false, that all flower gardens are creations that feature skunkweed, because for there to be any flower gardens that create skunkweed, let alone all of them, Area 2 would have to be open. And it's not. It's been shaded. But there's something kind of tricky about this argument, and that is that phrase, it is false that. Okay? Because I know by contradiction, if it's false that all flower gardens are creations that feature skunkweed, it has to be true that some flower gardens are not creations that feature skunkweed. Okay? And now this is a different kind of argument, because whereas it looked like before the conclusion statement was reflected by the Venn diagram, when I replace the conclusion statement with its contradiction, it no longer does. Because if it did, I would see an X here in Area 1, and there's no X in Area 1. And what that tells me is that this argument is invalid from the Boolean standpoint. It has that form of a universal premise and a particular conclusion. But I can come back and look at this argument from the Aristotelian standpoint, examine my F circle very carefully to see if there's only one area where all of the F can be, and sure as shooting, Area 1 is where all of the flower gardens are. All flower gardens are in Area 1, so if they're all there, there has to be at least one there. And now I get to mark a circled X, and now the argument shows, or I'm sorry, now the Venn diagram shows the conclusion of the argument, indicating that this argument is conditionally valid. It's valid from the Aristotelian standpoint, and the condition that has to be met is that flower gardens have to exist, and they do. So the argument is valid from the Aristotelian standpoint. So the takeaway from this problem is when we're doing Venn diagrams, we probably always want to get rid of that phrase, it is false that, using the squares of opposition and the rule of contradiction. All right. It is false that no incendiary devices are contraptions that misfire. Therefore, some incendiary devices are not contraptions that misfire. And again, I've got that phrase, it is false that. Well, if it's false that no incendiary devices are contraptions that misfire, it must be true by contradiction that some incendiary devices are contraptions that misfire. Now I can create my Venn diagram by marking it X in Area 2. That shows that there's at least one incendiary device that's a contraption that misfires. I don't see my conclusion statement, though. If we did see the conclusion that some incendiary devices are not contraptions that misfire, we'd see an X over here in Area 1, and we don't. So this argument is invalid from both the Boolean and the Aristotelian standpoints. Number 3, it is false that some pet lovers are people who think that animals are mere machines. Therefore, it is false that all pet lovers are people who think that animals are mere machines. Oof, we've got a couple of it is false that phrases. So we definitely want to get rid of that one in the premise. By using the rule of contradiction, if some pet lovers are people who think that animals are mere machines is false, then it would have to be true that no pet lovers are people who think that animals are mere machines. Okay, so now we can mark our Venn diagram. And again, we're in this position where after marking the premise statement, it seems to show the conclusion statement that it's false that all pet lovers are people who think that animals are mere machines, because Area 2 has been shaded out. And if there were any pet lovers that thought animals were mere machines, they would be right here in Area 2. So it has to be, if there's none of them there, it has to be false that all of them are there. All right? But that phrase, it is false that, it can be really tricky to work with. We want to get rid of it using the rule of contradiction. And now we have a conclusion statement that's an O statement. Some pet lovers are not. And we can see this argument has the form of a universal premise and a particular corresponding particular conclusion. And that argument is always invalid from the Boolean standpoint. And we can see now that the Venn diagram reflects that. Right? Because if the conclusion statement were reflected by this Venn diagram, we'd see an X in Area 1, and there's nothing there. So definitely this argument is invalid from the Boolean standpoint, but put on our Aristotelian goggles. Is there only one area of the P circle that's the only area where any P's could be? Yes, Area 1. So we get to mark our circled X there, and then we ask ourselves, okay, does the P circle refer to something that actually exists? Pet lovers. Yes, the world's a better place because of pet lovers. So the condition for validity has been met, and this argument is valid from the Aristotelian standpoint. All right. Finally, no werewolves are creatures who lurk about in the daytime. Therefore, it is false that all werewolves are creatures who lurk about in the daytime. Now again, I create my Venn diagram and it seems like it shows the conclusion statement, right? Because area 2's been shaded out, so it has to be false that all of the werewolves are there. There's nothing there, okay? But that phrase, it is false that. Let's use the rule of contradiction to get rid of it and replace it with what would be a true O statement. Some werewolves are not creatures who lurk about in the daytime. And now I can see clearly that the Venn diagram does not reflect the conclusion statement after it's been marked to reflect the premise statement. And that tells me, well, this argument is invalid from the Boolean standpoint, but because area 1 is the only area where all the werewolves can be, there's got to be at least one there because they're all there. But remember, for this argument to be valid from the Aristotelian standpoint, the Venn diagram has to show the conclusion statement, and the subject term has to be referring to an actually existing thing. And there are no werewolves. So we can't draw the conclusion that because no werewolves are creatures that lurk about in the daytime, which is true because there's no werewolves at all, it's not therefore true that some werewolves are not creatures. Some means at least one. So that tells us this argument is invalid from both the Boolean and Aristotelian standpoints because it commits the existential fallacy. If any of these were confusing to you or you want to go over any of them, just shoot me an email.